students, welcome to Ajax Academy YouTube channel. In this session, I am going to discuss waves. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. Introduction. Have you seen a pond? See, this is a pond. Yes. What about the state of water here? Is it at rest? See the picture. What do you observe when you drop a pebble at a point in the pond? Ripples on the surface of water are observed. Is the disturbance confined to a place? No, it spreads out in the form of circles from the point where the water surface gets disturbed. What have you observed when you put a cork or a piece of paper on the disturbed water surface? The piece of cork starts oscillating up and down about the mean position and does not move forward. What do you understand from this example? A disturbance is created at a point and it moves forward but not the particles of the medium. So, what is wave motion? Let us discuss. It is the disturbance that travels through the medium due to repeated vibrations of particles of the medium about their mean position. So, the disturbance that travels through the medium due to repeated vibrations of the particles of the medium about their mean position. The motion is being transferred from one particle to another without the transport of the particles of the medium. So, what is the quantity that is transferred during the propagation of the wave? That is energy. Do sound and light form waves? Yes. Does sound require a medium for the propagation? Yes. Without medium, sound cannot propagate. Sound cannot travel through vacuum. So, compulsory for the propagation of sound, material medium is necessary. Does light require medium for propagation? No, light can propagate even in vacuum. Does all the waves require a medium for propagation? No. Now discuss MCQs. Which of the following waves require medium for propagation? Electromagnetic waves, ultraviolet waves, light waves, sound waves. Which of the following waves require medium for propagation? Sound waves. For the propagation of sound, material medium is necessary. So, we require a medium for propagation. So, those are sound waves. What is transferred due to disturbance of medium? Energy, mass, particles, velocity. What is the transfer due to disturbance of medium? Energy. Next, which wave propagates in both medium and vacuum? Sound waves, mechanical waves, light waves, none of these. So, light waves propagates in both medium and vacuum. Now, discuss types of waves. Different types of waves. There are two types of waves, electromagnetic waves and mechanical waves. Again, in mechanical waves, progressive waves and stationary waves. So, mechanical waves are again divided into two types, progressive waves and stationary waves. Progressive waves are again divided into longitudinal waves and transverse waves. Okay, first waves. Waves divided into two types, electromagnetic waves and mechanical waves. Mechanical waves are again divided into progressive waves and stationary waves. Progressive waves divided into two types, longitudinal waves and transverse waves. Now, electromagnetic waves. The waves which travel in the form of oscillating electrical and magnetic fields are called electromagnetic waves. Oscillating electrical and magnetic fields are called electromagnetic waves. Such waves don't require any material medium for their propagation. So, they are also known as non-mechanical waves. All electromagnetic waves travel through vacuum with the same speed c as that of light. So, example. Now, discuss example. Speed of light c is equals to 3 in 10 to the power of 8 meters per second. Radio waves, microwaves, X-rays, visible and UV light. Now, discuss mechanical waves. The waves which require material medium for their propagation are called mechanical waves. These waves are also known as elastic waves because they depend on the elastic properties of a medium. Now, I'll discuss example. Sound waves, water waves, seismic waves, that is waves emitted at the time of earthquakes. Spring model for propagation of a wave through an elastic medium. See, this is the spring model for the propagation of wave through an elastic medium. Number of springs connected to one another, one end is fixed to a rigid support. The first spring is pulled to the left and released. It gets stretched. Due to elasticity, the first spring returns to the original size and stretches the second spring and so on. So, a disturbance moves from one end to the other. So, but each spring only executes a small oscillation but its equilibrium position. Now, propagation of sound waves through air. A small region of air is considered as a spring. So, it is connected to the neighboring regions or springs. When sound wave propagates through air, it compresses or expands a small region of air. So, this produces a change in the density and pressure in that region. So, delta P, that is change in pressure, delta rho change in density. Pressure is a force per unit area, so restoring force is proportional to change in density. In this case, changes in density is similar to the extension or compression in the spring. If the region is compressed, its molecules tends to move out and enter into the neighboring region. So, thereby increasing the density and produces a compression in that region. The region at which the density is less is called rarefaction. The air of the surrounding rushes the rarefaction regions. This shifts the rarefaction to the neighboring region. So, compressions and rarefactions move from one region to another. So, the atoms or group of atoms are in equilibrium due to the force from the surrounding atoms. If one of the atoms is displaced from its equilibrium position, restoring force is developed. So, disturbance produced by the force travel to the next atom and so on. The wave propagates through solid. Now, I'll discuss MCQs. The region at which dash is maximum is called compression. Mass, volume, density, velocity. The region at which density is maximum is called compression. The region at which the density is minimum is called compression, rarefaction, crust, trough. The region at which density is minimum is called rarefaction. The speed of light in vacuum is 2 in 10 to the power of 8 meters per second, 1 into 10 to the power of 8 meters per second, 3 into 10 to the power of 8 meters per second, 3 into 10 to the power of 7 meters per second. The speed of light in vacuum is 3 into 10 to the power of 8 meters per second. Thanks for watching this video.